Thank you for joining us for this Maptek webinar. For today's session, I welcome Product Manager Peter Odens, who will run through some of the upcoming stratigraphic modelling enhancements. You'll learn how to take advantage of these updates, ensuring you spend less time processing data, creating opportunities to apply your expertise to analysis and decision making. My name is Steve Sullivan. I'm a Technical Sales Manager for Mine Planning based in Adelaide. Along with Peter and the other members of our team, part of our role is to ensure that our application's functionality aligns with your needs and we feed your information back to our development teams. The enhancements you'll be seeing today are examples of functionality that has been added and finessed based on your input. If you have any questions during the webinar, you may enter them into the questions panel on the GoToWebinar interface, and we'll answer as many as we can, time permitting, at the end of the session. But for now, over to you, Peter.
Thanks, Steve, and good afternoon, morning, wherever you happen to be, and thanks for tuning in. So, as Steve mentioned, I'm the product manager for Vulcan and Eureka, and I guess ultimately my interest is in trying to make the software we provide as useful to you guys, the users, to get your solutions done. And today we're going to have a look at the sneak peek at some of the upcoming sort of geologically based goodies, and specifically in the stratigraphic side of things. So think coal mines, iron ore deposits, things like that, upcoming in both Vulcan and Eureka. Just before we get into the actual demo, I quite often get asked as the Eureka product manager why we actually put some functionality into Eureka rather than Vulcan. And there are several reasons for this, and some of them are technical, but fundamentally what we're trying to do at Maptek is blur the lines between individual products and basically provide the functionality inside the architecture and the software design, if you like, that is the best vehicle for providing the solutions you need to use. And in terms of Eureka specifically, I tend to think of it more and more now like a module of Vulcan, which just sits in the workbench and it does some things better than Vulcan can do. So for example, if you're trying to model a complicated 150 seam deposit in a Hunter Valley with lots of splits and faults and things, then you're not going to use something like Eureka because it's not designed to have all the rules and regulations and spec files and things set up to be able to do that. That's what Vulcan's all about. That's what integrated stratigraphic modeling is all about. And we'll have a little bit of a look at some of the new tools in that soon. But on the other hand, if you've been given a blast with a bunch of holes and some telemetry straight out of a drill rig, there's a bunch of CSV files, you just want to quickly drag it onto the screen, see it, view the traces, label it, associate geophysics LAS files, all in a very simple drag and drop method, then Eureka is ideal for that because it's designed to have that interactive, quick graphic interplay, if you like, with your back-end data. And one of the reasons it can do that is it was architected from the ground up to behave in that fashion. So if you sort of think of it in those terms, where especially now we have the workbench interface, as you'll see, where everything just basically sits in the one user interface, and half the time I can't remember what actual bit of the software I'm using. I'm just using the tool that does the job best. And even in terms of pricing, it's really a module we're thinking about, not another package. So today we're going to have a bit of a quick look at a few bits in Vulcan and a few bits in Eureka that are coming out around about the same time. We're aiming for middle of the year for version 11 of Vulcan and version 5 of Eureka. So the top two, throw and block faulting enhancements and the clipping design to fault blocks, are in the Vulcan side of things. And then the bottom two will be in the Eureka side of things. There are some other interesting stratigraphic developments happening in terms of coal washability and seam aggregation. And again, I'm sure we'll hear more about that in webinars to come. But for the time being, let's jump into the software proper.
The predominant stuff done in Vulcan is in the integrated strat modeling side of things. And it's one of those options or improvements, if you like, where there isn't actually that much to show you. The first is in the fault modeling. So as a bit of history, back in version 5 or so, we introduced the ability to use solid triangulated block faults as your fault domains. And they were very good in that they gave you a lot of flexibility. You could define your fault planes with as much detail as you required, handcrafting sections or projecting lines, however you wanted to do it. If you had to weave your faults in and out of myriad borehole intercepts, you could do that. And then make a solid, chop the planes up against the solid using something like multi-boolean tool to make mutually independent fault zones which you could then use through the entire integrated strat process from fixed map to the modeling to the hard model. And that gave very good results, and it was a very useful option. Its weaknesses were where you had smaller faults or areas where you had less detail, and you wanted to be able to simply just define a fault with a string and a dip and a throw on the points. And they didn't have to necessarily cross the entire deposit or cross each other to make these larger boundaries. So in version 10, we introduced the whole idea of an enhanced throw faulting, whereby you have a bunch of strings representing your faults. They have as a point value the W tag is the throw, and which way that throw goes depends on either the sign of the point or the direction of the string. And each point can also have a different dip value, and that's stored in the actual point name, point object name. And that went, again, was very successful, gave good results for simpler faults where people said, well, I think there's a fault there, has a throw of about this, and it's roughly the dip. But if you're going to try and then throw lots of drilling information and such, and you want to try and weave detailed fault planes in and out of this drilling information, it's quite difficult to do it with a fairly simplistic, plane pivoting around a string. So what people wanted and what we wanted was the ability to use the best of both worlds, which is to use this string-based throw faulting with its ease of use and simple setup and easy to CAD change, with the block faulting, which involves a little bit more effort. You have to know your triangulation tools a bit to make the solids, and but use them both together. Now, saying that is one thing, doing it is another, and what we've actually done is totally changed how this throw faulting works, in that behind the scenes it's actually doing block faulting. So all the hard work is done by Vulcan. All you do is set up the strings as you always have and fill in a few of the panels. In fact, the panel hasn't even changed, but behind the scenes it's all being done with block faulting, including using actual block faults. So the setup is nothing to really show you, but I'll give you a quick look at what it looks like. So I'm here in the workbench. I'm sitting in a Vulcan screen. I can then come and look at this. I actually loaded it in Eureka. So this is a Eureka window with the data loaded from Vulcan directly. So what we're seeing here, if I turn off this fault block, is a faulted surface, and you'll see that most of the faults have been faulted by these strings with the dips and the throws. If I turn those off, you'll see the broken surfaces there corresponding to that information from the CAD work. But you can also see that there's this major fault coming down here, which is not being created by a string. That's actually being created by two block faults, one of which I have loaded here. So I've used them both in conjunction. Oh, we're actually looking inside the fault there. And you can see that the major fault's been done by a large block fault, and there would have been two in this instance, and the minor ones have been done by the string fault. So being able to use those two in conjunction gives you another enhancement, a powerful enhancement on the stratigraphic faulting capability in integrated stratigraphic modeling, coming your way in version 11. The other enhancements, if I pop back to Vulcan World, is a smaller one. It's basically the ability, has always been there since block faulting was given to people, to include alternative CAD data on a per fault block basis. So if you want to control a particular fault block with its own pit pickups or underground mapping or seismic interps or whatever you have, you could do that, in addition to actually giving it the borehole data. But it assumed that the CAD data was, you already had decided that the CAD data you wanted to use was extend as far as you wanted to go. It didn't automatically clip that CAD data to a fault block. And some users were finding that was giving them not the results they were after, so they didn't have to go back and manually use a filtering tool to clip the strings by the fault block solid. So we've added the ability to come in and simply tick a tick box, and this tick box can correspond to every single bit of CAD data on that fault solid, or it can be drilled down to one particular horizon and just the roof or whatever. It's up to you how you use it, but at least you don't have to go out there and pre-process your data to use it in that fashion. So there's two of the strat enhancements coming up in ISM that will be most obvious to you initially, at least in version 11. And like I said, it's really the work done behind the scenes which is making that so much more useful. The other enhancements I'd like to talk about are in the Eureka side of things. So let's just jump into a Eureka window here. And it's really enhancements we've done in the stratigraphic realm. As you're probably aware, Eureka does a range of things from, all body modeling, implicit modeling type work to pure exploration type work and seismic, but it also has quite a powerful stratigraphic toolset. And that's mainly in terms of viewing and correlating and auto-picking lithologies. They don't have to be stratigraphic, they can be anything, but it's most useful in the stratigraphic realm, at least for this correlation work. And to show you how it works, what I'm going to do is I'm actually going to do it from scratch. So I have a location file here. Let's have a quick look at it. It's just a CSV file. Anything you use borehole-wise can be in CSV or in ISIS, and if it's in ISIS you can actually have a back-end ODBC if you want to, although I wouldn't necessarily recommend it from a performance point of view because Eureka has a live link. And we have a hole, we have a collar, XYZ, and some dip and bearing information. And the only trick here is make sure you know whether it's from the vertical or the horizontal. So to actually load that, I just have to drag that file onto the Eureka screen. And it's smart enough to know, do you want to load that just as points or as holes? I'm going to load it as holes. In this instance, the naming is simple enough. It's actually picked up the correct fields, and you tell it down here whether it's degrees from vertical or horizontal. And it will go and make for me a bunch of empty geology files, a header file, and a downhole survey file. Let's do that. I'm running out of names for this thing. So that's gone and brought it in. So these are in Eureka. They're basically empty holes. You can see, well, maybe you can't see, they're not all vertical. And they're currently viewed by the collar information. So let's just quickly change that view. Now you won't see any change because the geology is actually empty, but I'm going to load it up so it's going to be viewed with lithology and labeled. Just hit that. I'll leave that panel handy. So what I've also got in this is some downhole drilling information. So let's just quickly open that up, show you what that looks like. So anything you can bring in, either in the database already, or if it's external LAS files, downhole geophysics files, can be just dragged onto the screen and associated with those holes. So you can see here I've got the hole, some depth information, and I've got RPM, torque, air pressure, that kind of stuff. So anything numeric I want to bring in. And again, to load that, all I have to do is come into the actual setup of the database. And I don't have to go and reload or anything. I just say I want to add this extra information. I can go and check whether that information is in the right format, but I know it already is, so I'm just going to hit OK. So that's actually done it now. If I reselect those holes, I'll just have to quickly reload my visualization. You'll see now down the bottom here I have the lithology, which is currently empty, but I also now have all that extra information I loaded. So let's load, say, the torque trace. I'll just give that width of about 10. So that's as hard as it is. You can see the legend's been created all automatically for me. There's some coloring there. If those squiggles are a bit rough looking, we've got a nice little enhancement in the new version 5 of Eureka to do a bit of smoothing on the fly. It's all very dynamic and quick. You can make it histograms, you can make it labels. Now, I don't know about you, but if I'm using my geological eye here, I can see that there's a bunch of what looks like three horizons I can see in this data, as well as a bit of a kick at the top. Now, this is drill hole torque, so the kick I'm going to ignore. This, I think, is low torque based on the fact it's going through a coal seam. So I could come in here and select a hole and go to the edit option and start typing in to's and froms and fixing things up manually. But I'm not going to do that because I'm lazy, plus I've got Eureka to do it for me. So I'm going to let it pick the holes, and we've had this ability, it's going to pick the holes and pick the seams based on what I tell it. That's been around for a while. The new bit is actually correlating and giving it some naming. So let's quickly go through that. Creating intervals from downhole data. I'm going to write to the lithology field, call it coal, and I can use up to 3 traces or things from LAS files, but I'm just going to do it from just the one, the torque, and you can see it gives me a preview. I've picked up a bit of junk at the top, which I want to get rid of, and one seam in this instance. So the first thing I'm going to do is say, look, I know roughly the top half meter, just ignore it. Let's have a look at some of these other holes here. What else we got floating around? There's 2 seams there. And as we get further into the data, you can start seeing we're picking up those 3 seams. Okay, so obviously I'd spend a bit more time than this normally getting it right, but I can just quickly go, great, that's my first pick. And before we jump into the labeling, you can see now I have gone in and I've labeled those coal seams. And if I just quickly come in here and I'll turn off the torque trace so you can see what's going on. So again, I can keep that panel handy. I have 3 seams here and I've managed to miss most of the top. And again, I could come in, I could edit that, I could call it seam A, seam B, top seam, bottom seam, whatever. But I'm going to let Eureka do that because I'm also lazy. Would I like to label the seams? Yes, please. So this new function is going to write to an empty field, a formation field, or you can choose whichever one you want. It's picked up from my targeter run what I used, so it's going to use this CO pick as a starting point, and it's using that torque. And what it does is it gets signatures of all the different picks and uses those to try and correlate, right? And you can sort of see how that correlation is working if I do this preview business. It'll line it up and saying, well, here's how I've made everything horizontal. Here's how I think things match. And you can see, for the most part, it's done a pretty good job. So I'm happy with that. I'm going to leave it. You can dynamically get it to be more lumping or more splitting in terms of how many seams you get picked. But if I hit apply on that, it's going to go and right back to the formation field now. It's picks, okay? And you can see I have the A, B, and the C horizons here. If I just pick a hole by itself, I'm going to get one in the front row. So, hang on a sec. Maybe this one. You can see it's gone and picked. It's got the 3 seams that said, I reckon they're correlated as A, B, and C. And you can sort of check that correlation across the whole deposit. And for the most part, it's done a good job over here. You can see it's gone to D, E, and F with a few extra seams. Now that's fine, that's terrific, but again, in the real world, your seams are probably not called A, B, and C. So let's give it what we call a template hole. I can do that by using my editing tools. So if I come in here and right click on the interval, you know, these are the dynamic editing tools we've seen before where I can change thicknesses and things, but in this case, I just want to get my seam naming. So Eureka's had a guess at A, B, and C, but in reality, my deposit is called top, mid, and bottom. So hit OK on that. And what I'll quickly do is just relabel those holes based on the formation pick. So in this case, it's going to be formation. We'll turn off the geo label and apply that to all the selection. And you can see in here I have top, middle, and bottom. Actually, what I'll also do is I'll color that. So in this case, I'm going to use a pre-existing legend called legend number 3, I believe. And that has got the colors in it for my top, middle, and bottom. Okay, so let's use that again. So we can come in here and use the label seam intervals option. Interval field to label is formation. We're going to look for the value of CO. We're going to look at torque. Make sure that's set appropriately. We're going to skip the first half meter. And I can use a template drill hole. So if I just select one, grab this with my middle mouse button, and select all the holes. It goes and labels all those options, all those seams for you. So now I've got top, middle, and bottom labeled, and it's a good start. If I come over to this side of the deposit, you'll see there's a few where it's gone a bit funny. Let's have a quick look. Don't forget we have all the correlation tools. I can stick my hole names on here. Let's have a look at that. So now we know where we are. So let's pick a row across the guts here, and I'm going to throw that into our correlation view, which is a nice new goodie for Eureka 5, which throws you into a pseudo 2D window. I'll just change the background because although it looks fine on screen, I think broadcasting might not be quite so nice, so we'll make that black. Okay, so let's have a look. We've got top, middle, and bottom, and a few things gone funny here. So the first thing you can do in this view is you can align by any horizon you want, and I can also put on some dynamic correlation lines so you can see how things are joined. In terms of the work I want to do right now, I'm not so much looking at the structural differences. I want to do the actual where things sit. I've got a miscorrelated seam here, hole. So let's go and fix it up. So I come in and use my edit, and let's just get this so we can see what we're doing. So I think that that top unit is not actually untitled. That's really the top. This one here is probably mid. You can see how it's dynamically changing things. That one there is probably a bot, not boy, bot. This one here is also probably a bot. This one is nothing, so let's get rid of that. That, and that, and that, and that. And I've fixed up my correlation, so I can hit OK on that. And of course, I can, at any time, I can come in here and use my visualization tools on this. So let's have a look at our the actual torque trace we used in the first instance. What does that look like? Okay, maybe I'll kick that up a bit wider. And so we can check how it's come from the initial trace to the correlated seam. Where it was having some trouble, you can see that it's done very well actually to pick that signature at all, because that trace is pretty average. So this one here, okay, so that's not really top either. Let's fix that. Getting a bit finicky here. That's actually middle. And then basically you're done. You've gone and correlated it, and it's saved back to the database, be it CSVs or ISIS. And of course, you know, Eureka is not just a correlation tool. If you want to do some quick modeling for a blast pass or something rather, I can select the holes and say, oh, look, I want to model the top of the middle seam. So let's select that interval, and then we'll just throw a quick grid over that. And again, you can see it's very easily to set up. Just hit apply. There you go. You've got a model. Now I've got one strange looking correlation down there, but apart from that, I can fix it up. I've got a surface for the middle seam, and of course I could go back and sort that out later on. You know, there's another way of checking that something might be a little bit awry. So using these new tools in Eureka 5, I can quickly get a new bunch of blast holes someone's given you and some downhole torque, or if you've got given a couple of hundred holes from a neighbouring mine site or something rather, you want to associate your LAS files, just drag on the screen, same as the holes, associate them, and away you go. You've got all these tools. And like I said, if you start thinking about Eureka as a module to help with your geological stratigraphic work rather than getting a new package or that kind of thing, the way the workbench works is it's just another package, another module, if you like, sitting in the workbench interface along with your envisage windows, all that sort of thing. So it's becoming, you know, full and integrated. Any model I make in Eureka can be quickly converted to a triangulation and used directly in Vulcan, and vice versa. Okay, so I think that's probably all I want to show you right now. I'll throw back to Steve and any questions that might come up.
Thanks for the demonstration, Peter. Before we get on to some of the customer questions, do users need any particular modules to access these new tools when they're released?
The ISM, the integrated strat modeling functionality, will be part and parcel of anyone who has a GeoModeler license or GeoModeler upgrade. And the Eureka, a lot of what I showed you is part of the core Eureka package. The litho targeting and auto correlation side of things is an add-on module to Eureka.
Thanks, Peter. Your presentation has generated a few questions from the audience. Firstly, can you import fixed DHD and or raw map files generated from Vulcan into Eureka to use the automated seam correlation that you showed us?
You could, yeah, because you can output fixed DHD as a, I mean, obviously you're going to have some sort of correlation to start with to get fixed DHD to run, but if you want to check the interpolated version versus the input version, you can export fixed DHD as a drill hole format, which would just drop straight into Eureka, or you can even export it to an ISIS format, which would open directly in Eureka, and all the viewing and checking and correlation tools would be then directly available to you to use.
Okay, I guess on a somewhat similar line, can you drag and drop an ISIS database from Vulcan Explorer into the Eureka graphics window to display drill holes and their attributes?
Yeah, certainly. So this particular data set, what I'll do is I'll crank open a new viewing window, and got to get used to this whole Eureka thing of not being hung up on where you are in space. So I'm going to go to a Vulcan data tab here, and I can come down to the Vulcan headed databases. And if I was to grab an ISIS file like this one and just drag it on the screen, and basically that's pretty much all I got to do. The very first time I bring it in, it's actually loading it to the Eureka backend, and after that, it's in Eureka ready to use. And I'll just make the holes a bit bigger there, and I'll zoom in a bit. I'll put some labels on there for you. So I'm going to label it by lithology type. I view it by lithology type, and I'll label it by seam. Where's seam gone? Here we go. So yeah, it's ready to use straight away.
Excellent, Peter. Final question from a customer. They really like the seam intervals. Can we do this for assay rather than lithological data? Say, could the function select drill hole intervals data based on a composite above a specified grade?
You can certainly view any assay data as a label, as a downhole trace, or as a histogram type view. Can the function select drill hole interval data composite above a specified grade? Eureka won't composite it on the fly for you, but if you have, again, you can run compositing in Vulcan, and you can highlight certain aspects of the Eureka drill holes based on any criteria. So you can only show me the parts of the drill holes where, gold is greater than 5 parts per million or whatever, and so they would be rendered in full thickness, and the rest would be rendered as a stick. So there is that kind of thing. In terms of on the fly working on compositing, that would be an intriguing enhancement.
Yeah, I guess, Peter, maybe we'll address that in our future webinar on implicit modelling in coming weeks, and that may address that question as well.
Yeah, certainly. And as you may know, Eureka does have a full implicit modelling module add-on as well, where you can start making your ore bodies or stratigraphic implicit models based on drilling data and other information.
Okay, Peter, thanks very much. That appears to be all the questions for now. I'll just wrap that up. We've seen a showcase of what's being updated in Maptek stratigraphic modelling tools. Now, customers with current software maintenance can download the latest version of Vulcan and Eureka from users.maptek.com. If you've got an existing username and password, use that, and you'll be able to access the users area. Otherwise, on that users.maptek.com, there is a registration there where we will issue you a password and you can access that area. So both the latest versions of Vulcan 10.1 and Eureka 4 are available now. Of course, if you have any questions about Vulcan or Eureka, please contact your local Maptek office for assistance. You can find all the relevant contact details both on our website and on the current slide. If you'd like to view this webinar again or share with your colleagues, it will be available online at maptek.com probably early next week. While you're there, you can catch up on some of our past webinars covering a whole range of topics. Also coming up in the future geological webinars, we'll be covering new aspects in grade estimation and simulations, updates to implicit modelling, and a new Vulcan workflow and scripting function webinar. Feel free to let us know if there are any other topics you are interested in learning more about, and we'll consider them for future events. Finally, thanks again, Peter, and thanks for the audience for watching, and bye for now.